Hi everyone, in this video we will talk about trigonometric functions in right triangle. So we have certain type of trigonometric functions, out of which let's discuss first three. So first we have sine, cos and tan. Let's give this triangle name as A, B, C. Let's take this angle as theta. So when you look from theta, this side is called opposite. So that is important, okay? If this angle is theta, then this side will be opposite. Okay. Now, let me just give them all the names. So this side is opposite, so I'm representing O. This side will be adjacent, so representing by capital A. Don't get confused. So with this A and this A, and this is hypotenuse, so this is capital H. Now, if I look at sine theta, this is given by opposite over hypotenuse. So the shortcut for this is SOH. Sine equal opposite over hypotenuse. Next we have cos is equal adjacent over hypotenuse. This you need to remember, and the shortcut for this is C cos equal A for adjacent, H for hypotenuse. And the next we have tan theta is equal opposite over adjacent. So this is represented by TOA. T for tan, O for opposite, A for adjacent. So you can remember this so, ka, to. So, ka, to. Okay. Now the remaining three we have cosec, or you call it as cosecant. Cosecant theta is equal 1 over sine theta. So this will be equal hypotenuse over opposite. Now similarly here you have sec theta, or you call it as secant theta, is equal 1 over cos theta, and that will be hypotenuse over adjacent. Now pause the video and try to write for opposite of tan, which is cotangent theta is equal 1 over tan theta is equal adjacent over opposite. So once you find these three, then the remaining is just opposite, okay? You just need to remember which one is opposite to which one. So for sine you have cosec, cos you have sec, for tan you have cot, okay? Now let's take an example. For example, if this side is 13, this is 12, and this is 5. Hypotenuse 13, opposite is 12, and adjacent is 5. So sine theta will be equal to 12 over 13. Cos will be 5 over 13. Similarly here 12 over 5. I'm just putting the values, nothing else, okay? O is 12 from here, H is 13 from here. So I'm just simply taking the values, that's it. Now cosec theta is opposite, so this is 12 over 13, so opposite is 13 over 12. This is 5 over 13, so 13 over 5. 12 over 5, so this will give you 5 over 12. And that's how you will find the trigonometric functions for all the trigonometric functions. That's how you will find, okay? Okay, so next we will have find trigonometric values. So yeah, find trigonometric ratios and values. So let's say if we have a triangle PQR, let's give this PQR, so don't get confused, PQR. And let's say this side is X, this side is let's say 5, and this side is let's say 8. Now you have a given information. So if you have sine B is equal, sorry, this one is, let's say, sine r from here is equal 5 over 8. So this is r. I'm checking from this angle. Now this is opposite and this is hypotenuse, right? Sine is opposite over hypotenuse. So SOH, sine opposite over hypotenuse. And adjacent is x. So this is important, right? So how you will find all the side, which side is opposite, which side is adjacent, and which side is hypotenuse. Like this, you can give them the names. Okay, now next is you need to find all the trigonometric ratios for this. So you will have to find cos r, you will have to find tan r. Similarly, you will have to find cosec, cosecant, secant r, and cot r. So you will have to find all the trigonometric ratios. To do that, first you need to find the x, right? Because adjacent we don't know. And to find that, we will do square root 8 square minus 5 square. And that will give you square root of 64 minus 25. This is square root of 39. So x is equal to square root of 39. Now cos r. So the trick was CAH. So adjacent over hypotenuse. This will give you adjacent is the square root of 39 over hypotenuse is 8. Next, tan r. You had the short trick TOA. Opposite over adjacent. Opposite is 5. Adjacent is square root of 39. Now cosec r. Cosec r is opposite of 1 over sine r, right? Remember? And now sine r is 5 over 8. So this will give you 8 over 5. Now secant r is opposite of 1 over cos r, and this is square root of 39 over 8, so that will give you 8 over square root of 39. Now cot r was 1 divide tan r, and that is 5 over square root 39, so this will give you again square root 39 over 5. So that's how you will find all the trigonometric ratios for any triangle. Let's solve one more question. So let's say this time if we have a triangle, okay, okay. Let's say triangle X, Y, Z. This is 90-degree angle. Let's say this angle is theta. The given information you have sine theta is equal. So let's say this is 12, this is 13, and this is 5. So sine theta is given 12 over 13. This information is given. Now you need to find the remaining trigonometric ratios. Okay, so cos theta will be equal to, so from here if you look, this side is opposite, this side is hypotenuse, this side is adjacent. Cos theta is equal adjacent over hypotenuse. Tan theta is equal opposite over adjacent. And now the remaining is very simple, so you can do them by yourself. Cosec is 1 over sine theta, and sec theta is equal 1 over cos theta, and the last one is cot theta, which is cotangent theta is equal 1 over tangent theta, tan theta. So these three you can do by yourself. I will write for these only. So adjacent here is 5 over 13, and here opposite is 12 over 5, right? So this is how you will find the trigonometric ratio. Let's do one more question. Now in this right triangle, the given information is tan B is equal 3 over 7. This is the given information, and find the remaining trigonometric ratios. So let's say if this is A, B, C. I cannot give this as B because this is 90 degree, okay? So either you can start from here or here, no problem. You can take B here or here. So let's say this is angle B. So from here, the angle B, this will be opposite, this will be adjacent, and this is hypotenuse. So opposite tan, TOA, right? So this is opposite over adjacent. O is 3, adjacent is 7. So hypotenuse will be how much? Square root of 3 square plus 7 square using Pythagorean theorem, and that will be 9 plus 49. This will give you square root of 58. Now you just find the simply trigonometric ratio. So sine B is equal, now use the formula SOH, sine equal opposite over hypotenuse. Cos B is equal ca, so adjacent over hypotenuse. That's it. Now just substitute the values. Opposite how much? 3 over hypotenuse square root 58. Adjacent 7, hypotenuse square root 58. Now the remaining, again cosecant B is equal 1 over sine B. So that will be square root of 58 over 3. Similarly, you can find secant B and cotangent B by yourself. Okay, so that's it for this video. Find them by yourself, and there are few more topic in this video, in this topic. So I will cover them in part 2. The part 2 will be connected here. Using the eye icon, you can access the part 2. So that's it for this video. See you in the next one.